All right, you guys, let's review really quickly sort of what we covered today in class, and I'll go on to some of the new stuff. You're going to have a test Thursday. It's in 2 parts, meant to be 90 minutes, which means some of you will finish during class, but if you want a little bit of extra time, you need to find an open period, a lunch, or after school, you can come back and finish. Okay, we talked about just regular derivatives. We talked about this limit definition stuff. That's kind of more on the bottom of the barrel, in my opinion. Not super duper important. Equations of the tangent line, very important. So let's take a look. I started making some notes for you guys here. Now, I will go ahead and give you this on your test. Okay, in case you don't have it memorized yet, you'll need to have it memorized at some point. I will also let you use your best friend chart, okay, on your test. As long as there's nothing else written on there. Like, I don't want you to write a bunch of stuff on there. All right, just so that you can see the best friend chart and stuff. Okay? This is that limit definition of derivative stuff. If you get it, great. If not, don't spend too much time on it. This is very important. Equation of a tangent line. Okay? Whenever you guys see that, you go y minus y1 equals mx minus x1. x1 is always given. y1 is sometimes given. If not, you plug x into the original to find it. And m is you plug x into the derivative. Okay, we'll make a few more notes as we go through here. Okay, so we did all that. I think I'd actually like to redo number 16 because this was at the end. And I could tell I was like losing people a little bit. So let's go ahead and redo this question. All right, and we'll kind of go from here. And I'll do the whole, like that page. And I'll see if there's anything else that's going to be tested that I missed. Okay? All right. This is basically showing you what seeing if you understand what the derivative rules are. This is just a regular rule, number 16. It says if you're adding two derivatives, if you're adding two functions, you simply add the derivatives of each of those. So when I take the derivative of this, it's 2 and then derivative of t. And then when I made the derivative of this, it was 4, and then the derivative of r. I don't have to do a product rule or anything, then the numbers just stay out front. Well, since I'm evaluating now at t equals 3, I'm going to do 2 and then s prime of 3 for r prime of 3. Okay, let me go ahead and go up here. S prime of 3, if I come over here, S prime of 3 is 5. And then R prime of 3 is 3. So I end up getting 10 plus 12, which is 22. Okay? All right, that's how we do that one. Now, for letter B, you guys see this, I actually do have to do a product rule. Because I'm multiplying, and remember, product rule goes like this. I'm going to go ahead and write it above. The derivative of the first times the second by itself, and then the first by itself, and then derivative of the second. Okay? Now, at time 3, so it's basically asking me to do, okay, what's r prime of 3? What's regular s of 3? What's regular r of 3? And then what's s prime of 3. And all of that, you guys, is just going to come directly from the table. This tells me they're all at 3. It only gave me 1 row because that's all I needed. R prime is 3. S of 3 is 2. R prime of 3 is, wait, hold on. Oh, yeah. Sorry, I thought that was a prime right there. Okay. Regular R of 3 is negative 2. And S prime is 5. So this gives me 6 plus negative 10, which is negative 4. All right. And then for part C, I'm going to do a quotient rule. Now, the quotient rule goes like this. Derivative of the top times the bottom minus the top times derivative of the bottom over the bottom squared. Okay? So I am going to get, let's see, and these are all evaluated at 3 again. R prime of 3, which is 3, and regular S. Okay, and then regular R and S prime. And it's over S of t squared. It's over 2 squared. Okay, so it's going to give me 6 minus a negative, so 6 plus 10 over 4, which is 4. Okay, so it's just kind of testing your knowledge of product rule, quotient rule. All right. Try to move this up a little bit so I have more room on the next problem. Okay. Okay, cool. All right, we do want to know physics stuff. Let's write a note down for physics stuff. All right. Okay, here's what you need to know. All right, you guys. You have your regular, sometimes it's called S of t, sometimes it's called other, it can be called x of t or whatever, that's your position function. If I take a derivative of that, I get velocity. If I take a derivative of that, I get acceleration. Okay, and so basically what it's saying is I take derivatives to go between one and the next. All right, you definitely want to know that. Okay, other words that you guys need to know for the physics section, okay? At rest means velocity equals 0. Moving right or up or whatever the question might say is when velocity is positive. Moving left or down is when velocity is negative. Okay, so we have when it's at rest, it's not moving, and the velocity is 0. Moving right is when it has positive velocity. Moving left or down is when it has negative velocity. Then we have, okay, let's see, we have displacement. Let's say it's looking for the displacement on the interval from A to B. You literally just find f of B and f of A and subtract. Okay, it's basically just from the starting line to the finish line. So how far did you go? Remember, that can be 0 if you start and finish at the exact same place. This one's a little bit trickier though. Total distance. What you need to do for that is you need to find your start, you need to find your finish, and you need to find everywhere it turns around. Okay, and you need to find the distance between each of those points. So when it says total distance, you got to add in everything where it turns around. I'll show you guys an example of that in a second. And then the last thing I believe you need to know is, speed. Speed is absolute value of velocity. Okay? So if you know that stuff, you're going to be good for physics. I believe this is one multi-part question for the physics stuff. Okay. Sorry. All right, let's see here. This is my x, my position equation. Here's my velocity equation. Here's my acceleration equation. All right, those all just took derivatives. So to answer these questions, find the velocity equation. The velocity equation is 6t squared minus 6t. Find the acceleration. Acceleration is 12t minus 6. When is the particle at rest? Okay, remember, at rest means velocity equals 0. If I take out a 6t, I end up getting t equals 0 and t equals 1. So at 0 seconds and at 1 second. Okay? When's the particle moving left? Well, I'm going to do a sine line graph. Anything less than 0, like -1 when I plug it in, 6 times negative 1 is negative. Negative 1 minus 1 is negative. Negative times negative is positive. Between 0 and 1, if I plug it in, a half. 6 times a half is positive. A half minus 1 is negative, so it's negative. Bigger than 1, like 2. 6 times 2 is positive. 2 minus 1 is positive, so it's positive. So moving left or down or whatever would be this part. So between 0 and 1 second. Moving right or up would be the plus parts. Okay? When is the velocity equal to 12? Well, let's bring that over. So it says minus 12 equals 0. Let's factor out a 6. And then that becomes t minus 2, t plus 1. So the velocity is equal to 12 feet per second at negative 1 seconds and 2 seconds. Unless it specifically tells you the time can't be negative, we're going to go ahead and count negative time because it's right. That just means it happened before I started keeping track or whatever. Find the particle speed when the acceleration is 0. This is like kind of a two-part problem. First, I've got to see when the acceleration is 0. Well, that's at 1/2 a second. Finding the speed would be plugging in 1/2 to the velocity, which is 6 times a half squared minus 6 times a half, which is 1/2 squared is 1/4, so it's like 6/4 minus 6/2, which is 6/4 minus 12/4, which is negative 6/4. But because it asks for speed, I need to do the absolute value of it. So it's 6/4. It doesn't give me units, like inches per second or whatever, but it's just 6/4. Okay? Now, displacement and distance. We're going to go ahead and do both. I'm going to do them down here. Okay, the displacement from negative 1 to 3 versus the distance from negative 1 to 3. Okay, the displacement means I find out, I gotta use x, where my particle is at negative 1, where my particle is at 3, and how far apart away they are. Well, I'm going to plug that into my original question. Okay, at negative 1, that's going to be negative 2 minus 3 plus 2. That equals negative 3. At 3, that's going to be 54 minus 9, that's 45, 47. Okay, the distance between there is 47 plus 3, which is actually 50. So the displacement is 50. Distance is going to be different because I need to find out where it's at negative 1, 3, and anywhere it turns around. Now I found that over here before. The particle is at rest at 0 second and 1 second. That's where it's turning around. So 0 and 1. Okay? Because I want to find basically from negative 1 to 3. Okay, I already figured out at negative 1 it was at negative 3. At 3 it was at 47. Going back into here again, plugging in at 0, it gives me 2. And 1, it gives me 1. Okay, let's find out how far away each of these are. That's a distance of 5, because it's a negative 3 to a positive 2. That's a distance of 1. That's a distance of 46. So it's a total distance of 52 units, or whatever. Okay? So you can tell it's a little bit different than the displacement. All right, cool. Let me go ahead and move those off to the side so we have room for 18 and 19. Oh, 18 is calculator. I want to go over this with you again, though, to make sure everybody's got this. All right, this is all going to be done on your TI calculator. So you go out and go ahead and pull out your TI calculator. Anytime I ask you guys for like find this with your calculator, okay? That means we can't actually do this by hand. All right, let me start with, hang on a second, let me bring this in here. All right, the big thing that you guys want to remember is math 8. It's right there. It says derivative. So the first part, it wanted me to find the derivative at 3. So x, the equation was 4 to the x minus 3x, and it wanted me to find the derivative at x equals 3. That is my answer right there. With a calculator question, you guys, you do not have to even do a derivative by hand. You want to make your calculator do it for you. Now I can do a double derivative. The way you do it is a little tricky though, so check it out. You go math 8, you take the derivative with respect to x of this. Actually, hold on, let's do it differently. We take the derivative of the derivative. Okay, now right in here, we put 4 to the x minus 3x. And right here, we're just trying to take the derivative the first time around, not at a specific number. So the first time around, I'm just doing a derivative. Then I'm doing the second derivative at 1. But when you're doing a second derivative, you only want to put that on the outsidemost part. So my second derivative at 1 was 7.687. Now to graph it, I'm going to go down and turn this off real quick. The regular graph of 4 to the x minus 3x looks like that. If I type in math 8, 4 to the x minus 3x when x equals x, it will graph that for me. And there's a derivative. Okay? So that's all calculator questions. All right, awesome. For number 19, we need to write a couple more things down in our notes right here. Okay? After the physics stuff, we need to go ahead and write this down. Average rate. Oops. Let me get this back up here for you guys. Sorry. All right. Average rate of change versus instant ANEOUS rate of change. Sorry about that. There you go. Okay. You guys, an average rate of change is literally just a slope. You do f of b minus f of a over b minus a. The instantaneous rate of change is the actual derivative. All right. Okay. And you need to know the difference between those for sure. So let's go to number 19. All right. The average rate of change from 1 to 2. So the way I want to do this, you guys, is I want to do f of 2 minus f of 1 over 2 minus 1. I don't take a derivative or anything. I just plug it in. So at 2, it's going to be 4 over 3 times 2 squared, which will be 4 over 6 squared, 4 over 36, which will be 1/9, I believe. Okay, for 1, it'll be 4 over 3 times 1 squared, which is 4/9 all over 2 minus 1. 1/9 minus 4/9 is -3/9 or -1/3. That is your average rate of change. That's the slope between 1 and 2. Now to find the instantaneous rate of change, we take the derivative of this. Guys, if you expand that out to 9x squared, you can bring the x squared up, and that's fine. So let's rewrite this before I start as 4 over 3 squared is 9x squared. And then I can bring that up. So it's actually 4 over 9 x to the -2. Okay? So the derivative of that is going to be negative 2 times 4 is 8 over 9. And then when I subtract 1, x to the -3. And on the question it said, find the instantaneous rate of change at x equals 1. 1 squared is 1, so it's just -x over 9. So that's more accurate because that's the instantaneous rate of change. Cool. All right, the last bit of stuff, we're going to talk about continuous differentiable. Okay, let's write this stuff down too. All right. Continuous means the limit as I approach from the left is the same as the limit as I approach A from the right is the same as the point. So the left-hand limit and the right-hand limit have to equal the point. Think about that. The left-hand limit, the right-hand limit, and then there has to be a point there connecting them, and it's going to be continuous. Okay? In order to be differentiable, basically the derivatives have to be continuous. Now, it's easier to talk about differentiable by saying things that are not differentiable. Okay, and there's basically 3 things. If you have a break in the graph, it's not differentiable, or a hole. If you have something like that, that's called a sharp corner. It's not differentiable. Or basically, if you're going from the left and the right and the 2 sides don't meet up, it's not differentiable. Okay? So if the left derivative does not equal the right derivative, it's not differentiable. All right, so let's take a look at some more questions on this. Okay, it says the graph of x to the 2/3 is shown. Is it continuous at 0? That's a big yes, because you guys, there is no holes, there's no breaks in the graph, there's nothing. Is it differentiable at 0? No. And the reason why is it has a sharp corner. Okay. Next one, is it continuous at 0? It is. I can take 0 to the 1/3 and that's fine. Is it differentiable? This is actually also no. And the reason is because it has a vertical tangent line. Okay, a vertical tangent line, meaning it goes straight up and down. All right, and so it doesn't have a derivative at that point because the derivative is undefined. Okay, here's how we do these other ones. All right, I'm going to do the first one, and then you guys can practice a couple. To tell whether or not it's continuous, what you want to do is plug 0 into the top, okay? Plug 0 into the bottom. As long as those 2 sides meet up, yes, it's continuous because I got 1 and 1, okay? Now, we're going to take the derivative. So we're going to say, okay, the derivative of this is, okay, the derivative of x squared plus 1 is 2x. The derivative of x squared plus x plus 1 is 2x plus 1. And this is when x is less than or equal to 0 and greater than 0. And we're going to plug it in again. Okay, and we're going to say, well, 2 times 0 is 0. 2 times 0 is 0, plus 1 is 1. These do not match up. So is it continuous? Yes. Is it differentiable? No, because the derivative has a jump in it. Okay, the derivative has a jump. All right. This one, plug in 0. 0 squared plus 1 is 1. Plug in 0. Negative 0 squared plus 2 is 2. Is it continuous? No. And honestly, if it's not continuous, it can't be differentiable because differentiable functions have to be continuous. So I can immediately say no for differentiable. All right, 24. Is it continuous? Well, if I plug in 0, I get 1. If I plug this in, negative 0, I get 1. So yes, it looks like it's continuous. Now I'm going to see if it's differentiable. So I got to take the derivative of each one. Okay, well, at 0, that equals 0, and that equals 0. So it looks good to me, and yes, I think it is differentiable. Okay, because the regular function was continuous, and so was the derivative. All right, last question, you guys. Anytime on a test it underlines a word for you, that means it's important. Find the points where the graph has horizontal tangents. That means the x and y coordinates, and it says like maybe 2, so maybe there's more than 1, I don't know. Another word that you need to know, let's go ahead and write it down here. Okay. Okay, a horizontal tangent means whenever you see that word, derivative equals 0. Okay? A vertical tangent means the derivative is undefined. All right, so check it out. The derivative of this, and set it equal to 0, if I factor out a 3x, divided by 3, I get x equals 0. Add over the 2, I get x equals 2. The way that I actually find the y coordinates where that happens is I plug those points into the original. 0 to the third minus 3 times 0 squared plus 3 is 3. 2 to the third minus 3 times 2 squared plus 3. That's 8 minus 12 plus 3. That's negative 1. Okay, those are the points. That's it. Hopefully you guys feel pretty good about that and you feel ready for your test. I will collect the packets on Thursday and give you your test. Awesome.